Hi everyone, in this tutorial we're gonna practice how to visually investigate the association between elevated blood lead level in children and age of households across the Ohio state. So this is an application of GIS in heavy metal studies in environmental health. So previous GIS-based researches have found that old housing is a common risk factor of the blood lead level in the children. So this part summarize the studies that use GIS for investigating the association between the elevated blood lead level in children and some factors. They found that old housing is a common risk factor. Okay, old housing, and in a variety of in various parts of the U.S., Tennessee, Kentucky, South Carolina, Georgia, but we don't have any study in Ohio. So in this lab we're gonna investigate the association between the exposure to the lead level and blood lead level and the age of households in Ohio. So let's Google Ohio Department of Health. And click the first link, Ohio Department of Health, odh.ohio.gov. And after that, data and stats, and scroll down and select Ohio Public Health Data Warehouse, and I think here we can find the lead data. So here we have lead data and some description of the data. This data set contains data related to blood lead testing for Ohio children from 2016 to present, and also so basically no level of lead in the body is considered safe. Medical attention is needed when a child under 6 years of age is confirmed to have an elevated blood level of 5 microgram per deciliter. So 5 microgram per deciliter or higher is considered as the elevated blood lead level. So these are some other information about the data. Just look at the information. So go to the reports tab, and so what we're gonna do is that we're gonna first download the data of the number of the children tested for the blood lead level, and after that we're gonna find how many of these children had elevated blood lead level, and finally we found the proportion of the people that have been that had elevated blood lead level. Okay, so first go to the number of Ohio children less than 6 years of age tested for lead, and then click here. We're gonna have the data for each county, okay, because we're gonna bring the data into GIS. So the row should be the location based on the county, and the column has to be lead testing, okay, for all of the years, and then click export data. So let's see what is our data. So for each county in Ohio we have number of the tests for the children, okay, how many children tested. You can see that the number is different, so there are huge difference between the numbers, so we can't use the numbers, okay, so we have to use the proportion. So we also need to see how many of these total numbers have elevated lead level, okay, so let's save this as copy these two columns in a new file, new, as the, and then paste values, paste it here, total test. because we're gonna bring the data into our GIS, just don't forget to put the underscore between two names. And also we need to find the elevated data, right? So again, so this one was for the number of the tests. We have to go back and lead data, and here under reports we have to go to this part, elevated blood lead level in the same year. Okay, so they have more than 5 microgram per deciliter, under 6. So the same people, the same year, but here they have elevated blood lead level. Okay, so go to this part. Again, your row should be location and county. And how about the column? Column should be lead testing, and here we have to select elevated blood lead level. Okay, we don't need this one, so we can remove this. So lead testing, elevated blood lead level for each county, and then click export data. So let's look at the data. So this one, you can see the values are so much smaller compared to the whole number of the people. Okay, so this one is elevated blood for each county. So we can just copy this and then paste it here as values. Okay, so you can see that these two counties are the same, so you have to make sure that they refer to the same location. Okay, and here, so we can remove, now we can remove it, and here is based on the elevated count. Okay, so what will be the proportion will be number of so let me, proportion will be number of the, open the parentheses, number of the elevated over the total number. Okay, so the probability that a person in a children under 6 years old can have elevated blood lead level will be this value. Okay, so for this county, Adams County, is 2%, and then you can apply this for all of the cells. So for the probability that the person that can have elevated blood lead level for this county is higher, right? And so this is the probability. You can time the whole value, time multiplied by 100 to avoid the decimal numbers, and then apply it. So some areas have very low probability of the elevated blood lead level, some areas will have higher, right? So let's save this data, save as in your lab 6 folder with the name of lead Ohio proportion. Oh, that's fine, lead Ohio, and with the type of comma separated values. Save, yes, and then close it. Okay, so that's for the first part. So we have the lead data among the children. Okay, proportion, so we need this information. We also will use this field for the join. Okay, so based on the literature that we saw, the age of building is also a common risk factor in elevated blood lead level, right, in many regions in US. So let's try to find a factor that can describe the age of the buildings. Okay, the median age of the buildings for each county in US. I think we can find the data from American Fact Finder, which has demographic data. So Google American Fact Finder. So Google American Fact Finder, and then go to this website. If you remember, it was under download center. So I know the data sets or table. Click next, select the program, American Community Survey, and the latest one, and then click next. So your geographic area is at the county, and select Ohio. All counties in Ohio, add to your selection. Next. So here the variable that can describe the age of households can be median year structure built. So median year structure built, and then click OK. So it gives us the median year of the structure. Okay, so and select it, and then click download, and include descriptive data into row. We don't need this one, so click OK, and then click download. So this one is in the ANN. So this one gives us, for each county in Ohio, we have the median year structure built. Okay, so let's remove this field. So let's first copy this field into copy. Don't work within the zip file, okay, so it won't save. So you have to go to your Edge lab and then paste it as I don't know, old age of building, age underscore building underscore Ohio, and then open up the CSV file, remove the first one and remove the ID. So the error, margin of error is not really necessary. So here is the year. So in order to join it, we need to we can copy these two fields, okay, and then put it in and then paste it here. Paste as value. Paste the spatial, paste value. So let's compare. So this one, Adams, Butler, Columbiana. So let's compare these two fields that they refer to the same location. So for example, Highland. So Mage. I think both of them are referred to the same location, right? Winton, Wayne. So we can now remove this one, and now we have the age of a structure. So let me change this to age of building. Okay, so now we can again save this information and then save, and okay, so I think now we have age, building, proportion, and everything is ready. So we can use county name for the join operation. So if you open up your ArcMap and load and then navigate to lab 6 folder, so we can add the shape file. So we're gonna join this lead information, which also has the information of the age of the building, right? We're gonna add this to the shape file based on the common field, the name of the county. So right click on the name of the county, join and relate, join. So for the shape file was let me see, for the shape file is name, and for this one is county name. So join and relate, join. For the shape file is name, and for the CSV file county name. Keep all records and click OK. And now if you open up the attribute table of the shape file, we can see this information has been added to the ArcMap, to our shape file. So this is how we prepare the data. This is how we bring the data into GIS. So we know that this is not a permanent shapefile, so let's export it as in lab 6 folder with the name of lead underscore OH, but this one is the shape file, okay, it's not a CSV file. And then okay, now we can remove everything else. So now our data set has been prepared, which was the most important part of our analysis. So the next step is to open up attribute table of the lead Ohio, and then we're gonna make some graphs to examine the association between the elevated lead level and age of households. So let's start with the histogram. If you right click on the age building and then statistics, so here you can see most of the buildings, the age of the building, most of the buildings were built before 1990 or 1985, something like that. So most of the buildings were built before the 19, and most of them are old buildings, right? And also here the average of the age of the buildings across the Ohio is 1969, okay? And also the standard deviation is 8. We can also look at the proportion of the elevated blood lead level, and you can see that most of the counties have the proportion of the elevated blood lead level less than 5% have very high proportion, okay? So most of them have, a few of them have elevated blood lead level greater than 5%, and also the on average is 2. So the proportion, most of them have the proportion of the 2%, 2.7. So these are some the histogram of the proportion and also the age of the households. And now we're gonna test the association, or visually compare the association between the age of the buildings, age of the households, and the proportion of the elevated blood lead level. So if you click on table option, create graphs. So first we start with the scatter plot. So if you select here scatter plot based on this layer, lead Ohio, and Y field should be proportion, and X field is age of the building. So that's very interesting that you can see there is a negative association when the age of the building increases. As the age of the building increases, you can see the proportion of the elevated blood lead level decreases. So you can see that there is obvious negative association between the age of the building and the proportion of the elevated lead levels. And that's very interesting findings of this study. So let's remove this legend, and so the color match the color of the layer. So we can, instead of rectangle, you can use circle, change the size of the circle. That's 4. And you can also add a trend line, okay? If you go to the add and then new function, here you can add a trend line scale to your scatter plot. So you can see there is an obvious negative association between age of the building and the proportion. And what else? So you can show the label. So it dropped from the 4.45 to, so this one is not a real value, but if we continue this trend, so there will be almost 0. So next, so let's uncheck this one, and let's remove the graph legend, remove the trend, click next. So here you can put a better title for your graph, for your scatter plot. Instead of graph of lead Ohio, you may type age of building, so age of household versus versus what? Elevated blood lead, right? And so you can make this 3D or not. Graph legend again. We don't need a legend for the graph. So for the left part, instead of proportion, we can type proportion of the blood lead level, or elevated blood lead. Okay. And the right, we don't have anything. For the button, age of the household. Age of household, and in the parentheses we can type year. Okay. Or household year. This one is better. So household year, visible for the top, not visible, and then click. I think everything is okay. Finish. So this is your map. This is the relationship between age of households and elevated blood lead level. So you can also copy this map and then paste it here. Okay. If you select, for example, this county, you can see one county will be selected. So for example, you want to see which county has very old age of the household and median age of the household, and also elevated blood level. Where is this county? You can only select this and you can see this is here. Okay. So so it's very interesting. And the next thing is, so this is the, you can add this into your output map. The next thing is we also need to add the insert another, let me open, insert the histogram, but this time from here, create graph, and for the histogram graph, for the blood lead level, lead Ohio, and then for the age of the building, you can also here change number of the bins to, for example, 80 bins. So you can see most of the households have a very old buildings. Okay. And what else? Click next. So age of building, histogram or frequency of buildings. Frequency of buildings. And so age of building, or we can type, so in the button we can type year, and in the left count. So everyone knows that histogram, the y axis is count, right? So count, we don't need these two. Graph legend, we don't need that one. And also we can also add, copy this and then paste it to the here. Oops. Let me use this one and then bring it here. So frequency of building, and also you can also create a histogram for the frequency of the age of the buildings, and also make a map of the proportion here. Okay, very easy. Properties, symbology, quantities, proportion, maybe natural break 5 classes, that's fine. So very low, low, medium, high, very high, and properties. And here is the map of the proportion. And you just need to organize this your output layer. But one thing that you can do is change the orientation of this map page and print it up to portrait. Let me add another data frame, and this time the map for the age of the households. So proportion age of buildings. So instead of natural break, maybe equal interval. So the age of the buildings equal interval makes more sense. And so you can see we have another map, shows age of the buildings. So this one should be for the, yes, this one is for age of the building. So you can add a title for here, age of the building. This one is for Lead, Ohio. Okay, so let me add a set guideline to divide the map. Add another guideline here and a guideline with this size here. So change the size of the map to this part, and also if I put this on the guideline, so these are the same size. What's this? Let me move this guideline to here. Just to make sure that both of them have the same size. So when we are close to this guideline, it will snap to this area, to these lines, and then click full extent, both of them have the same size. You can also use the guideline for this one. So age of the household, frequency of the building. You can also add information, legend, north arrow, and all of the information, necessary information. This one is for the lead, proportion of the lead. You can see this county have higher proportion of the lead, but it's very interesting that this is not Cuyahoga County here. Doesn't have let me see. So it was built in 1955, so it should be, so this one should be the color should be reversed. Okay, so this one is older, right? So older, if you use the reverse color, that would make more sense, or maybe another color such as this one, but the red one means it's older. Okay, so that makes more sense. So these areas have older and also have higher elevated blood lead level, and also here is the scatter plot showing the relationship.